Hello class. So in this video, we're going to proceed from where we left out last time. So this time around, magsa-start na tayo with the discussion of infinite limits. So when we say infinite limits, yung value ng mga limits natin, which is L, approaches infinity or is at infinity rather. So in the later sections of differential calculus, mapapansin natin na there will be times kung saan yung limit natin ay positive or negative infinity. So, kailan lang? So, kumbaga, discuss lang natin kailan lumalabas yung mga infinite limits natin. So, by definition, mathematical definition natin, we say that the limit of f of x as x approaches a is equal to infinity if we can make f of x arbitrarily large for all x sufficiently close to x is equal to a from both sides without actually letting x be equal to a. So, ganito lang yan. If the limit natin as x approaches a becomes a very, very large positive number, then therefore, kumbaga habang yung x natin papalapit ng papalapit sa a but not exactly equal to a, at yung trend is we are approaching infinity, then therefore, our limit is positive infinity. Now, ganun din naman, if we are also trying to substitute a value of x that approaches a, close to a, but not equal to a, and the value gets gets smaller, bigger and bigger in the negative side, then, kumbaga negative na value, tapos on both sides, then we have a limit at negative infinity. So, an example na very familiar na tayo kanina is the function 1 over x. So, ilang beses na natin nagamit to. So, diretso na natin. This is also the same values na ginamit natin kanina. Kung mapapansin, the value of f of x, which is our 1 over x, as we approach 0, as we try to have a value that is closer and closer to 0, we will see that from the left-hand side, we will have a value of f of x that is increasing in the negative direction. So from negative 1 to negative 10 to negative 100 up to negative 10,000. And if we will go for a value of x that is much, much closer to 0, we will arrive at bigger values of f of x in the negative direction. So therefore, the limit, or to be specific, the left-hand limit of 1 over x as x approaches 0 is equal to negative infinity. On the other side, the limit, the left-hand limit of 1 over x as x approaches 0, coming from the right side, kasi nga right-handed limit tayo, that is equal to positive infinity. That is because from the positive side, we are trying to approach 0, so 1, 0.1 up to 0.001, we arrive at an f of x that is equal to 10,000. And as we go smaller pa dito or closer to 0, so gawin natin 0.00001, palaki lang ng palaki yung f of x natin. So therefore, the right-hand limit or right-handed limit of 1 over x at x is approaching 0 is equal to positive infinity. Now, since the left-hand limit is approaching negative infinity and the right-hand limit is approaching positive infinity, they are not converging. They are diverging away from each other. So still, the limit does not exist. So, hindi naman na-violate yung kaninang sinabi natin that for this function, the limit doesn't exist at x is approaching 0. So, ito rin yung problem natin kanina. Ayan. So, ito rin yung figure na ginamit natin. Next, another example. So, evaluate daw natin yung mga limits na to. That is the right-hand limit and left-hand limit and the normal limit of 6 over x squared as x approaches 0. So, for this one, gawin lang din natin yung ginawa natin kanina. So let's start with the one-sided limits. So start tayo with the right-handed one. That's the limit of 6 over x squared as x approaches 0. Now, mapapansin natin, this is a rational na ano rin kasi na ano 'di ba? Na equation kumbaga. So, kung rational yung equation natin or yung function natin, magkakaroon na tayo ng idea na kasi 'di ba, ang nangyayari is itong x natin will be approaching 0. So, ibig sabihin, pababa ng pababa yung value nito. And habang bumababa yung value ng x natin as it approaches 0, paliit ng paliit yung denominator natin. And habang lumiliit yung denominator, ang tendency is kapag 'di ba, kapag nagde-divide tayo sa isang maliit na denominator, ang mangyari is yung term natin is lalaki, 'di ba? So 6 over as very 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 small na value ng denominator that is almost approaching 0 will result into a very large number. So in this case, as x approaches 0 but not 0, palaki ng palaki yung term natin na to. So this term is going up. So therefore, papunta tayo ng positive infinity. So ganun din for the left-hand limit. So for the left-hand limit, we will also be approaching 0. Kasi ito, naka-squared to, di ba? Kanina kasi, 1 over x lang. Now, this time around, naka-square siya. So, even if manggagaling tayo from the left-hand side, meaning the value of x will be less than 0, thus, it will be negative. We will have a negative x, let's say negative a na lang, negative a squared. So, kahit na anong gawin natin, kahit na gano'n ka-negative, yung ilalagay natin na value ng a dito, and then as it approaches 0, ay magiging positive yung denominator natin. And yung denominator natin will be positive and will be a very, very small number since it is approaching 0. If that is the case, similar tayo dito. We will have a numerator that is 6 and a denominator that is approaching 0. And an approaching 0 na denominator will result to a term that will be a very, very large number. So therefore, the left-hand limit of 6 over x squared as x approaches 0 is also positive infinity. So kung ganun yung case, our left-hand limit and our right-hand limit is equal. So kung ganun yung case, we have a normal limit. And our normal limit is equal to the left-hand and right-hand limit natin, which is infinity also. If we draw the graph, ito yung kakalabasan niya. Makikita that at our point of interest, no, at x is approaching 0, both our function is increasing, no, papunta sa very high na value. So it is not hindi siya magmi-meet, yes, but it is both approaching positive infinity. So even using the graph, makikita natin na pwede rin natin gamitin yung graph mismo to reinforce our findings earlier that the normal limit natin is infinity. Ayan. So, kung i-discuss natin kanina ay infinity limits, kumbaga yung limit mismo yung infinity, what if naman na yung x natin is approaching infinity or negative infinity? So, ano naman yung case natin? So, ibig sabihin, by definition, ito yung gusto nating sabihin. We are trying to find the limit of a function, let's say f of x, as x approaches either positive infinity or negative infinity. So to do this, what we're going to do is actually substitute or assume that we're going to substitute a very large number sa value ng x natin. Kasi it's approaching positive infinity halimbawa. Then what we should do is imagine natin or let's base from our knowledge in algebra and other mathematics, ilagay natin ano ba yung dapat na value nung isang function kapag pinalitan mo siya ng isang term na may x kung papalitan natin siya ng sobrang laking value on the positive or on the negative side. So for this one, ayan, so bigay tayo ng mga examples. No? The best way to understand this is by solving. So let's start at a very simple one lang. Let's say, for example, we are asked to get the limit of x squared as x approaches positive infinity. So in this case, ganun lang, i-imagine lang natin that we are going to substitute a very, very large number for our function, which is x squared. So imagine, kung magsasubstitute tayo ng very large number at x squared, let's say for example, 1 million, and then i-square natin siya, makikita natin that as we approach bigger and bigger number, which is infinity or positive infinity, the value of our limit or the value of our function is also increasing. Specifically, it is increasing in the positive side. So therefore, our limit for x squared at x, as x approaches infinity is positive infinity. Because as we approach infinity, meaning as we substitute x that is bigger or that gets bigger and bigger yung value, our limit becomes is also approaching infinity. So what if naman hinahanap yung limit of x squared but x natin is approaching negative infinity. Negative infinity. So, apply lang din natin yung alam natin in mathematics. So, remember, if negative infinity to and naka-square siya, it's like, pag nag-square tayo ng negative na number, the result is a positive. So, it's like this, no? Kuwari na lang mag-assume tayo na nag-substitute tayo ng negative infinity dito, but it is squared. So, since even yung ating exponent, ang mangyayari dyan is, magiging positive to pagka in-evaluate natin yung exponent niya. So, therefore, this function is also approaching positive infinity. Next, what if x cubed naman? So, limit of x cubed as x approaches negative infinity. So, in this case, we will have negative infinity cube. Now, kung ganito yung case natin, remember that kung cube to, yung exponent natin ay hindi even number, it's an odd number, then that is negative times negative times negative. And that will result into a negative value. A negative value that is very, very high. So, meaning, ang limit natin of x cubed as x approaches negative infinity is negative infinity. So, that's just an example, no? So, kapag may mga ganyan tayo, madali na pala nating ma-identify ano yung limit natin. Now, gawin natin is, gawin natin medyo mas mahaba yung function natin. So, let's say for example, yung limit natin, hinahanap sa atin is the limit of a function 5x, o 5 lang, 5 plus 2x minus x cubed. Tapos, from x, with x approaching negative infinity. Now, for problems like this, what we need to do is hanapin na lang natin kung anong term yung pinakamalaki yung weight. Meaning, ano yung pinakamabigat sa lahat ng term na to. So, we have 5, we have 2x, and we have negative x cubed. If we assume, let's say for example, a large number, but it's not infinitely large, then given this equation, alam natin kung sino yung pinakamagiging malaki yung effect doon sa ating limit. And that is this term because the degree is 3. As compared to this one, 2x, and lalo naman ito, wala man lang siyang x na nakamultiply sa kanya. So therefore, ang pinakamalaki yung impact natin will be this term. So ang gawin na lang natin, tanggalin na natin tong other terms na to. Pwede na natin silang tanggalin. And we can simply just evaluate the limit of x cubed as x approaches negative infinity. And na-solve na natin yan kanina, and yung answer natin is negative infinity. Yun. Kaso, hindi ko pala na ano. May nakalimutan ako. Minus x cubed. So, that's minus negative infinity cubed. So, that's negative infinity times negative 1. So, that is positive infinity. So, that is the limit of this function. So, that's a technique na pwede natin gamitin or shortcut na pwede natin gamitin. Instead of evaluating or substituting a very large number for each na value ng x, kunin na lang natin yung pinakamabigat. And in this case, ang pinakamabigat is yung negative x cubed. So, unlist na natin yung iba. Yan, ilagay ko yung negative, no? It's negative x cubed. Alisin na lang natin yung ibang terms kasi ito lang yung relevant sa kanila. Let's have another example. Let's say, for example, we are asked to get the limit of 3x squared minus 5x raised to the fourth power as x approaches negative infinity. So, ganun din. Kung anong ginawa natin kanina, ganun yung gawin natin ngayon. Let us try to see which of these two terms yung mas mabigat yung rate or mas mabigat yung weight natin. So, obviously, mas relevant tong term na to because the degree is 4. So, tanggalin na natin to and let's just evaluate the limit of negative 5x raised to the fourth power as x approaches negative infinity. So, yung limit natin therefore will be negative 5 times negative infinity raised to the fourth power. Since this is even, so ibig sabihin nito, magiging positive na to. Kasi negative times negative times negative times negative is positive. Yan. So, matitira na lang is negative 5 times infinity. Tapos, we know that any number multiplied to infinity is basically infinity also kasi it's a very large number. So, makikarry lang natin tong negative sign na to. So, we will have negative infinity. So, that is the limit of this equation or this function. Yan. Next, paano naman kung rational yung natin, function? Let's say, for example, we are asked to get the limit of 1 over x as x approaches infinity. O, ganun din. Apply lang natin yung basic knowledge natin about infinity and algebra. We know that when we have a very, very large denominator, in this case, that's x, and we're going to replace it with a very large number since x is approaching infinity, ano yung nangyayari sa buong term na to? So, what happens to that term is that it gets very small or smaller and smaller and smaller until such point na it's already approaching 0. So, therefore, if ang hinahanap is the limit of 1 over x as x approaches infinity, then it's like saying we have 1 over a very, very large number. And that means that this 1 over infinity will become or will approach 0. So, ang limit ngayon nitong 1 over x as x approaches infinity is equal to 0. Now, what if naman the limit daw, we are asked to get the limit of x of 1 over x rather, as x approaches negative infinity. So, ganun din, we will have 1 over negative infinity, but we know 0 pa rin yung answer. And yung 0, hindi naman, that's neither positive nor negative. So, hindi na natin lalagay na negative. So, still, pareha sila ng limit natin. Now, i-apply natin yung ganitong concept in another problem. So, let's say, for example, we have the limit of 1 over x squared naman as x approaches negative infinity. So, ganun din, this will be equal to, since naka-squared to, we'll just have 1 over positive infinity sa ilalim. And similar lang siya dito sa nasa taas. So, therefore, our limit is also equal to 0. Kung napansin, medyo mas madali ito gamitin for, kung rational yung function natin, medyo mas madali siyang i-evaluate or hanapan ng limit kasi nga, nagiging 0 siya. And 0, kapag 0 yung limit natin, or 0 yung nasa equation natin, di ba mas madali siyang gamitin kasi talaga namang ginagamit natin yung 0 as compared to infinity. Now, isip tayo or gumamit tayo ng mas komplikado na mga rational function. Let's say, for example, we are asked to get the limit of 5x plus 2 over 7x minus x squared. That is at x is approaching positive infinity. So, how do we solve this one? So, pagka ganito, di ba, kung titingnan natin, meron tayong 5x plus 2. So, we will have 5. This is basically, since we're approaching infinity, our numerator is infinity. Di ba? Kasi that's 5 times infinity or a very large number. We have a very large numerator. Now, ganun din dun sa baba. Kasi, dun sa baba natin, we have 7x. So, 7 times a very large number of a large value of x approaching infinity minus another value that is approaching infinity, mataas din yung makukuha nating denominator. So, pwede rin natin gawin dyan actually is i-cancel na natin to because ito naman yung mas malaki yung weight. But whatever the case is, ang point natin is we will have basically an infinity over negative infinity. Kung ganun yung case, mahirap na i-decide natin or mahirap i-determine ano yung limit natin kasi hindi ka naman basta-basta makakapag-divide ng infinity over infinity kasi hindi naman siya variable, di ba? It's just a placeholder for a possibly large, very, very large number. So what we can do is, as I've said earlier, mas madali kapag rational, di ba? So ang gawin nating rational lahat ng function na to. So what we will do is, let us multiply the numerator and the denominator by 1 over x squared para mawala lahat ng x doon sa ibabaw. So, ang kakalabasan niyan, class, is ang kakalabasan natin is we have the limit of 5 or 5x times 1 over x squared. So, we will have 5 over x plus 2 times 1 over x squared. So, that's 2 over x squared. Over, ganun din dito. So, 7x times 1 over x squared, that's 7 over x. Tapos, minus x squared times 1 over x squared. So, that is minus 1. So, eto, mas madali nang evaluate to. Why? Because all of our x's are nasa denominator. And if infinity yung value or approaching infinity yung value ng x natin, kamuta ko isulat, x natin, then it becomes a very, very small number and pwede na nating i-assume that these fractions or rational expressions are equal to 0. Diba? So, ang mangyari, this 5 over x will be equal to 0 plus 2 over x squared equal to 0 over 7 over x will also be equal to 0 minus 1. And 0 over divided, 0 divided by negative 1, that is just equal to 0. So therefore, the limit of this function, the limit of the function 5x plus 2 over 7x minus x squared times at x is approaching positive infinity is equal to 0. Yun. So ganun lang. Next, let's have another example. We are asked to get the limit of 5x minus 7x cubed over 2x squared plus 14x cubed minus 9. Sorry, ang pangit talaga ng sulat ko pagka sa graphics tablet. As x daw approaches negative infinity. So, pwede natin gawin yung ginawa natin kanina. No? Gamitin lang natin yung ginawa natin kanina na process. That is, ginawa nating rational yung lahat ng terms natin. So, to do that, kailangan matanggal yung lahat ng x sa numerator natin. We multiply the whole equation or both the numerator and the denominator by 1 over x cubed. 1 over x cubed. So, ang kakalabasan is the limit as x approaches negative infinity ay magiging 5 over x squared minus 7 over x cubed or 7 na lang pala kasi makakancel na yung x cube, minus 7 over 2 over x plus 14 minus 9 over x cube. So, yun na lang yung matitira. Now, we can evaluate this pa na. Since this, magkakaroon tayo ng division by a very large number, this will be equal to 0. This will also be equal to 0. And this will also be equal to 0. So, ang matitira na lang is, ang matitira na lang is 0 minus 7 over 0 plus 14 plus 0. So, wala na itong mga to. Ang matitira is negative 7 over 14. That's negative 1/2. Now, meron tayong technique dito actually. So, we are asked again. So, ito yung shortcut na ibibigay ko, no? We have 5x minus 7x cubed over 2x squared plus 14x cubed minus 9 as x approaches negative infinity. Negative infinity. So, ano yung pwede nating shortcut dito? Ang gawin natin, tingnan natin, class, kung meron tayong parehas na numerator or parehas na degree ng x doon sa numerator and the denominator natin. So, meron. In this case, sa taas, that's 7x cubed. Sa baba, that's 14x cubed. So, ang gawin lang natin, yung highest degree is yun na lang yung i-retain natin because sila naman yung malaki yung value. So, tanggalin na natin tong 5x, tanggalin na natin tong 2x squared, tanggalin na natin tong negative 9. So, ang matitira na lang is negative 7x cubed over 14x cubed. So, i-cancel na natin tong dalawang x squared na to. Ang matitira is negative 7 over 14. That's the limit. And that is also equal to negative 1/2. Ayun. So, yun na yung shortcut. Ayan. So, pwede rin natin itong i-apply into other problems or other functions as long as kaya nating i-cancel or tanggalin yung mga hindi ganun ka-relevant. Meaning, yung walang masyadong weight. So, yan. So, yun. Pwede tayong gumamit ng shortcut. Ayan. So, that is it for the limits at infinity. We are now going to discuss continuity na mismo. Limits at infinity. So this time around, we're going to discuss continuity na. That ends our discussion with limits. Okay, so proceed na tayo with the next part, that is continuity. Now, kaya natin huling inaral yung continuity, inuna natin yung limits, that is because we need to know the definition of limits to have a formal definition of continuity. So, a function f of x daw is said to be continuous at a certain interval or at certain value x is equal to a if the limit of f of x as x approaches a is equal to f of a. Now, meaning, if you substitute f of x, if you substitute a to your value of f of x, that will be f of a, it should be equal to your limit. Kung equal ang limit mo, then you are continuous. Your function is continuous at that value of x that is approaching a. So, ganun yung definition natin ng continuity. So, para masabi natin that a function therefore is continuous, we need to assume or we need to solve for both f of a and the limit of f of x as x approaches a. Also, it's also implied na syempre para mabag-equal mo sa silang dalawa, dapat at least both of them should exist. So, dapat nag-exist si f of a mo and dapat the limit of your f of x as x approaches a also exists. Now, let's look at this example. So, given the graph daw of f of x shown below, determine if f of x is continuous at x is equal to negative 2, x is equal to 0, and at x is equal to 3. So, ito yung graph natin. Ang tinatanong is, continuous daw ba itong f of x natin at this point? First one is at x is equal to negative 2, this point. X is equal to 0, itong point na to. and that x is equal to positive 3, which is this point. So, pinapaalam lang, tinatanong sa atin kung siya ba ay continuous. Now, to determine if it is continuous or not, gamitin lang natin yung definition. So, we just need to find the value of f of negative 2 and compare the limit of f of x at as x approaches negative 2. So, ganun din, for x is equal to 0, we need to find the value of f of 0 and i-check natin if it is equal to the limit of f of x as x approaches 0. So, ganun lang. So, ganun din for f of 2. Ayan, para malinaw. Equal ba siya sa limit of f of x as x approaches 2? And for positive 3, kailangan yung f of 3 natin is equal to the limit of f of x as x approaches 3. Kung masasatisfy natin yung equation na to, then they are continuous at that point. Let's try to do that. Ayan, nilagay ko yung graph sa taas para may kodigo tayo. So let us first start at x is equal to negative 2. So first na gawin natin, hanapin natin if there is f of negative 2. May f of negative 2 ba tayo? Hanapin natin yung negative 2. Ito yung point na yon. So at negative 2, the value of your y or the value of your f of x is positive 2. So therefore, f of 2 exists. F of negative 2 exists and it is equal to 2. However, if we try to solve for the limit of f of x, I mean if we visually observe, does the limit of f of x as x approaches negative 2 exist? It doesn't. Kung makikita kasi natin, this is your negative 2 coming from the left side, it approaches positive 2. Coming from the right side, it approaches negative 2. So therefore, negative 1 rather, hindi sila nag-converge into one single value. So that means that the limit does not exist. So by definition of continuity, the function is not continuous at x is equal to negative 2. Ano yung reason natin? There is no limit. So hindi natin pwedeng ma-equate yung value ng function natin at negative 2 since wala tayong limit at that point. Next, we have at x is equal to 0. So let's try to find f of 0. And at f of 0, this is the point, ang value ng f of x natin is positive 1. So therefore, f of 0 is equal to 1. Now, let's try to find the limit of f of x as x approaches 0. So ito yung point na yon. This is also the point at which gusto nating malaman kung may limit tayo or wala. From the left side, as we go from the left approaching 0, we are converging to a value of 1. Now, from the right side, from the positive side, this point approaching 0, papunta ulit tayo ng positive 1. So, therefore, the limit exists. And the limit is equal to the value at which the left-hand and the right-handed limits are converging. And that is 1. And mapapansin natin, equal yung f of 0 with our limit of f of x as x approaches 0. Since equal sila, then the function is continuous at x is equal to 0. And lastly, we have at x is equal to 3. Now, at x is equal to 3, we also need to find f of 3 and then the limit of f of x as x approaches 3. Now, tryin po na natin hanapin yung f of 3. Pag tinignan natin sa graph, yung f of 3 natin, it exists because at x is equal to 3, nandito yung point na yon, yung ating x is negative 1. So therefore, our f of 3 is equal to negative 1. So take note, hole to, no? Butas yan. So there is a hole there. Meaning, wala tayong value dyan na nakapantay dun sa graph. However, meron tayong value for that specific value of x. That is x is equal to 3. And that is negative 1. So therefore, our f of 3 is negative 1. Next, we now try to find the limit of f of x as x approaches 3. Kung manggagaling tayo sa left-hand side, which is this point, halimbawa, galing tayo sa left, papuntang 0, we can see that we are approaching a value of f of x that is equal to 0. Now, from the right-hand side, from the positive side, or from the, from the side na mas malaki kaysa sa positive 3, if we come from this point, papunta sa x is equal to positive 3, we are also approaching the value 0. So therefore, the limit natin of f of x as x approaches positive 3 is equal to 0 because the left-handed and the right-handed limits are equal to 0. Now, are they continuous? Is the function continuous at x is equal to positive 3? No. Bakit hindi? Because our f of 3 is not equal to the limit of f of x as x approaches 3. So therefore, it is discontinuous. So, medyo obvious na siguro. Another way we can determine is if a function is continuous is by, again, visual inspection. So, ganito lang yan. Kung nado-draw natin yung curve natin at mapapass through natin yung point na yon of concern without lifting yung pencil natin, then the function is continuous in that value of x. So, in this case, halimbawa, at x is equal to negative 2. Yan ba continuous or hindi? Ang gawin mo, i-trace mo yung graph. If matitrace mo yung graph and hindi aangat yung lapis mo, then therefore, it's continuous. But in this case, makikita natin na kung ititrace ko yung graph, pagdating dito, tatalon ako dito sa baba. So, kailangan kong iangat yung lapis ko. Ganun. Now, for x is equal to 0, ganun din. Try natin i-trace. I-trace natin na madadaanan natin yung x is equal to 0. Now, can I trace it at hindi ako lalagpas sa 0 or hindi ako aangat yung lapis ko? Yes. So, hindi ko inangat yung stylus ko, nadaanan ko yung x is equal to 0. So, therefore, it's continuous or the function is continuous at that value of x. And finally, sa x is equal to 3, ganun din yung gawin natin. Kung ititrace ko siya at nadaanan ko yung x is equal to 3, makikita natin na pagdating dito sa hole, kailangan kong bumaba dito. And then, tatalon ako dyan, tapos tatalon ako pabalik dito. So, therefore, inangat ko yung lapis ko or yung stylus ko. So, it is not continuous. Okay, so yung ganong klase ng legit naman yun. Pero, syempre, if you're asked for the proper definition, the method talaga na dapat ginagawa natin is ina-equate natin, tinitingnan natin kung equal yung f of a and yung limit of f of x as x approaches a. No? But yun nga, ang shortcut natin is by tracing the graph. Now, let's have another example. We have determined where the function below is not continuous. So, ang tanong naman dito is, alam natin hindi continuous tong 1 over x na to. Now, ang tinatanong na lang, ano value ng x hindi siya continuous? Where the function is not continuous. So, yun yung hahanapin natin. Now, in order for the function to be discontinuous, yun nga, kailangan hindi natin masatisfy to. Kung hindi natin masasatisfy to, then ibig sabihin, this is not, this function is not continuous. So, simply put, we need to find, kapag pinapahanap sa atin where a function is not continuous, then we need to find a value of a wherein the limit of 1 over x as x approaches a will not be equal to f of a. So, yun lang yung kailangan natin gawin. So, alam natin na this is rational function to. And kung rational function to, asymptotic, yung magiging values of x natin at the point at which yung denominator natin will be 0. So, kung ganun yung case, then magkaka-idea na tayo where the function will be discontinuous. Kung hindi pa kayo convinced doon, what we can do is try to graph that point. If we graph if i-graph natin yung function natin, ito yung kakalabasan. And if we will do the trace method, makikita natin that as x approaches 0, kailangan nating tumalon papunta dito sa taas para matrace natin siya. So therefore, it is not continuous. Now, where is it discontinuous? And at the point wherein we had to make the jump. And that is at x is equal to 0. So, ganun lang. No? Tapos, yun nga, given of our knowledge with rational functions, na, di ba ano to, analgom pa din. So, rational functions, asymptotic, may mga asymptotic tayo na curves, kumbaga. So, in this case, since it's 1 over x, then, di ba, in any rational function, magkakaroon tayo ng asymptote at the values of x, or at any values of x, na gagawin niyang 0 yung denominator natin. In this case, the value of x at which gagawin niyang 0 yung denominator is also at 0. So that is why the interval at which magdadiverge yung ating function or ating graph is at x is equal to 0. So this is the point at which hindi siya continuous. Okay, another example para mas maging malinaw yung pinaliwanag natin kanina. We have h of t is equal to 4t plus 10 over t squared minus 2t minus 15. Same ng question. Hinahanap saan discontinuous to. O alam na natin that this is not continuous. Ang tanong na lang, at which point it is not continuous. So since this is also a rational function, we just have to find the values of t at which yung denominator natin is magiging 0. So in short, hahanapin natin yung roots nito. Diba? Kasi if you substitute the roots to the value of the denominator, this will be equal to 0, or the denominator will be equal to 0. So that is what we're going to find. So kunin lang natin yung t squared minus 2t minus 15. Yun lang naman kasi yung kailangan natin. Wala tayong pakialam pa dun sa kung ano yung nasa taas. So if we factor out t squared minus 2t minus 15, we will have t minus 5 times t plus 3 is equal to 0. So therefore, yung values ng t natin, or the roots of our polynomial na nasa denominator, will be at t is equal to 5 and at t is equal to negative 3. Now, kapag sinubstitute mo yung positive 5 sa denominator natin, this will be equal to 0. If you substitute negative 3 dito sa denominator natin, this will also be equal to 0. So those are the points kung saan discontinuous yung function natin. Why? Because those are the points wherein asymptotic yung graph natin. So if we will graph it, ito yung magiging itsura niya. So ito, ginawa ko to sa isang online grapher. Pag ginraph natin yung function na to. And true enough, that is at this point, this is approximately at t is equal to positive 5, at t is equal to negative 3, and this point, which is approximately at t is equal to positive 5, makita natin na nag-diverge from each other yung graph natin. So, kung iti-trace natin yan, makikita mo as I am approaching t is equal to negative 3, pababa yung value natin. And then, I need to jump dito sa taas para matrace ko pabalik yung value. So, inangat ko yung stylus ko, it's not continuous at this interval, which is negative 3. So, ganun din, kung dadaanan ko yung t is equal to 5, bababa ako dito, pero kailangan tumalon ako dito sa taas para madaanan ko yung t is equal to 5. So, therefore, inangat ko yung lapis ko, that is a discontinuous function. Or the function is discontinuous at t is equal to positive 5. Ayun. So, ganun lang yung ginawa natin. So, another way to solve this is, yun nga, ang pwede natin gawin is find f of 5 and then, tingnan natin if it will be equal to f of, h pala yung gamit natin. So, pwede pa nating another solution that we can do is that substitute natin yung, or kailangan nating masatisfy yung equation for continuity. And that is, at h, yan, tinutoyo yung aking stylus. That is at h is equal to 5 to further, further reinforce na tama tayo ng sagot. So, h is equal to 5 should be equal to the limit of your h of t as t approaches 5. And makikita natin, they cannot be equal. Because obviously, for 1, yung limit nito will either be approaching positive or negative infinity. So therefore, x na agad. Kasi, hindi naman mag-equate sa infinity itong h of t natin kapag pinalitan mo siya ng 5. So yun. So that's another, kumbaga, reinforcement na ay tama, the function is discontinuous at that point. So, tulad ng sinabi ko kanina, these functions are continuous. Why? Because kapag tinrace natin siya, hindi ko kailangang iangat yung stylus ko, makukompleto ko yung graph natin. So, for this one, this is the graph of sin x. Kahit magbigay ako ng any point of x in this graph, let's say at x is equal to positive 5. So, ito yung point na yon. So, kung susundan ko yung graph natin, dadaanan ko yung x is equal to positive 5 without lifting my stylus. So, ibig sabihin, continuous yung function natin. So, ito yung point na yon. Kung gusto ko siyang daanan, madadaanan ko siya, hindi ko kailangang iangat yung lapis. So, therefore, it is continuous. Ganun din dito. This is the graph naman of x cubed minus 4x squared minus x plus 10. Makikita natin na walang putol. So, ito naman yung example ng mga graphs na discontinuous. So, ito rin ay lahat ng to mga examples na na-discuss na natin kanina. So, we have ito. Makikita natin g of x natin. Tuloy-tuloy tayo. However, pagdating dito sa point na to, kung saan x is equal to positive 2, bigla tayong tumalon dito. And then, tsaka tayo bumalik. Tapos, para matrace yung graph natin. So, meron tayong hole dito sa point na to. Now, ang tawag natin sa ganitong klaseng discontinuity is hole discontinuity. Obviously, kasi may hole dyan. Kaya hindi natin siya matrace is because may butas yung curve natin. Next, the graph of h of t is equal to if 0 if t is less than 0 and 1 if t is greater than or less than 0. Ito rin yung graph na na-discuss din natin kanina. So, mapapansin na hindi rin natin siya pwedeng i-trace because pagdating ko dito, kailangan kong tumalon papunta dito sa 1. So, hindi siya continuous. Now, ang tawag naman natin sa ganitong klase ng discontinuity is jump discontinuity. Kasi, yun nga, tumalon tayo. Next, ito naman kanina, this is the graph of of 1 over x. Kaka-discuss lang natin. Makikita natin that the discontinuity is coming from the fact that approaching 0 from the left side, we are approaching negative infinity. And approaching 0 from the right side, we are approaching positive infinity. So, ang tawag naman natin sa ganitong infinity discontinuity ay infinite discontinuity. That is because at that interval or at that point, the curve diverges away from each other papuntang positive and negative infinity respectively. Now, we can further classify itong mga discontinuity na to. So, itong si whole discontinuity, if we will remove, diba? If we will remove the condition that at x is equal to 2, your function is equal to 6 or g of x is equal to 6, we can remove the discontinuity. So, kaya ang whole discontinuity, it is a discontinuity na tinatawag din natin na removable discontinuity because we can remove the discontinuity by removing certain parts of our equation. However, for the jump discontinuity and the infinite discontinuity, we cannot just alter this equation and then magiging continuous na yung function natin. So, therefore, pasok sa category na tinatawag natin na non-removal discontinuity si jump and infinite discontinuity. Yun. So, na-classify pa natin ngayon yung mga discontinuous na function natin. Ayan. So, that is it for our discussion for Chapter 2. So, that is continuity and limits.